Alrighty folks, welcome back to Abdec. Last time we left off, after finishing puzzle 15, we figured out two rules, the dots and the letters, and I left it at puzzle 16, which is the last one in the noun section, before we get to punctuation. And I guess we can see what's coming up. You might notice we're in different lighting now because it's night, and so we're using artificial light, and it also means there's going to be like shadows cast from my hands. I guess there were probably shadows in the other one, although the lighting's probably a bit better as well. Whatever. Hopefully everything's still visible. I'll try and stop like casting a shadow over the book. Puzzle 16. Let's do it. So. Oh gosh, 7 Bs. Sure, 7 Bs. We're probably going to need the plastic sheet. Let me grab that. For a moment there, I couldn't actually find it. It's so transparent. Okay, 7 Bs. These two. Oh, so what's it going to mean that they're in this? They're next to each other? Well, I can figure that out, can't I? Because it's impossible for there to be, like, I was wondering if it's 2 Bs, would they want to be in an area that's like the shape of 2 Bs? I mean, I guess technically that's possible if I were to do something like this. Like that's a shaded area and it's 2 Bs big. Like maybe that's what it was. Or like another thing that would definitely satisfy the rule I've got so far is simply covering up these 2 Bs with a single B shape. So it might be that. Okay. Because those Bs are both in an area that is B shaped. Like if you think about the rule as being a letter must be in a shaded region that is the shape of the letter that it is, then and apply that to each letter individually, then that B was in a region that's B-shaped, and that B was in a region that was B-shaped. I guess so far I don't have any reason to believe that combining them is possible, but I mean, if I were to do that, can we figure it out just based on numbers? So 7 Bs will be 21, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Not easily. You also need to be covered. Okay, so let's just imagine possible ways of like having these be like this, right? If it were like that, I'd be putting 5 more Bs in there, and this would be cut off, this would be cut off, this would be cut off, and this would be cut off. It's not feeling like a very, like this space existing makes me feel like there's going to be something in there. A B. There's going to be a B. There's going to be a B in there. And then that space feels useless, but that might end up being useless, and that might be fine. Okay, so actually, what's left over after that? Because that crosses off a bunch of spaces. So I guess we've got 5 left, so that'd be 15 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we could drop at most 3. I mean, so like let's imagine 1, 2, 3. I mean, I'm going to struggle to do 5 for sure. I need some way of figuring out that it's definitely not the case that my instinct is that I'm just doing something like this. But okay, so I guess that was one way of laying it out, but did I prove that it's not possible? Not really. Like that again, like this. So I mean, so like immediately if I do something like this, I've lost 4. I think I had 3 to spare, right? If I do that instead, I've lost 4-ish. Hold on, that. I mean, I'm losing a lot, yeah. It feels like it's not possible that way, at the very least. So then other things that could be done. I mean, there's many ways to arrange that, right? Like if I'm assuming that they can join up, it could be like this. That feels like it cuts too many out, doesn't it? Can I get 5 more B's in there? 1, 2, 1, 2, 3, 4. Yeah, it's not going to happen. But then that could go over there. Okay, there's got to be a better way of thinking about this. I mean, the other thing is it kind of feels like, since this is the last puzzle in nouns, it's probably not the one teach me a new rule. But they've put these together for a reason. I guess to teach me the rule of like, well, they just have to be individually satisfied. But it'd be nice to prove it. Also, we've got another dot behind it. I wonder if it'll be a case of like, oh, you have to go back at some point and read something from the ones that have circles behind them. And is that a complete circle or is it some other shape? Because that feels like that would, I'd be able to see the edge of the that bit there. I don't know. 7 B's. 21. 21. If like we're only doing 1 here, then that means basically it means 4 will be taken away. And that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Which is enough for all of them. But only if they could all fit. Which they obviously can't. Like, I guess like that would be off limits. For anything, what else would be off limits? If that has to be covered, I mean, it could be like that and like that. And like that. Oh, this is kind of scary. This is kind of scary. Feels like there should be a smarter way to approach this. It's definitely 7. Yes, it's 7. 7 B's. I do really want to prove that it's not possible once I've put in, like if I join 2 together here. And the main difference that causes is that there'll be more places where I can't go because otherwise it'll change the shape. But there's just a lot of options. Like there's this and this and that and that and that and that. I think there's 6 options. It would feel like a less elegant rule, but I'm not going to cut it out just because of the elegance. Okay. What can we figure out? What can we figure out? Well, first of all, both those are going to be covered. That's true. And you're going to be covered. Good job. Now, assuming this isn't connected to these, like the most efficient spacing feels like it would end up being, well, there's like this, and then that would be used, so it would be like that, and that, and that. 1, 2, 3, 4, 5. Ooh. Ew. Okay, well, I'm struggling to fill it in like that, so let's try a different arrangement at the top. Yeah, maybe starting at the top here is actually a better way to do it. So like this, like that, like this. That's 3. But then this feels ambiguous. So okay, so that shape up at the top left makes me think, to avoid like there being an ambiguous situation, you're going to have to be there, and there's going to have to be something here. Otherwise, that could just shift up and down, and that's not going to be connected to these at all. So that's probably going to be true. In which case, what does that mean for the rest of this? It probably means. What do I think it means? That you're left empty? No. 1, 2. Well, if there's 1 here. 1, 2. So that's 4, 5, 6. That feels good. And then that would be forced to be there. 1, 2, 3, 4, 5, 6, 7. I don't feel 100% confident on that. Like, that's assuming that is the rule. If the rule is simply that they have to be satisfied individually, then I think this is unique. Again, because if that weren't there, that would be an ambiguous positioning. So then that has to be slotted in there to force that to be there. Well, okay, but I guess that's not an argument for this necessarily being unique, because let's say that could go up and down. So where would you go? Well, I don't think they would fit in. It doesn't look like it would. So I'm pretty confident that's unique, but I don't know for certain. And then if one of these were down here, I can't prove it, but it feels like if any of these were like stuck to this and like crossing off a bunch of options around it, it feels like there just wouldn't be space left over, right? I think so. I think so. And if we did like, let's say that those 3 and then those 3, and then we'd have to do like that, and we'd be wasting so many spaces. 1, 2, 3, 4, 5. I think it's this. Okay, I think it's this. I'm going to go ahead and believe. Well, maybe we should do more of the things, although we're moving on to a different letter. Okay, I think it's that. We're going to accept it. Can't remember what I just did. Well, I've still got it drawn on there. I didn't wipe it off. So it was here, here, another one here, another one here. So that's 1, 2, 3, 4, 5, 6, 7. I think so. Not 1,000,000% confident that I'm right on that, but mostly. Okay, 17. A and C. Okay, so here we're going to have to figure out like what C is based on, because we haven't been given the shape of C, based on what would be unique. And I think I see it already, right? Because like this has to be in a region that's A-shaped, and C has to be in there as well. Well, where could A be such that something could be, such that another thing could be shaded in that isn't connected to that? I only see one way it could happen, right? If the A were like this, then there's no space occupied that isn't adjacent to A. So we need to put A in a position where there is a space that isn't adjacent to A. So that means here. And so therefore C is just a single square. Okay, cool. Neat. Is that the next one? 17, 18, yep. Cool. A, B, C, C. Okay, well, so then if these need to be in regions that are C-shaped, then that means that. Well, unless my like theorized rule from before is true, but we have no reason to believe that at the moment. A, B. Okay, so now it's about fitting in. Shall I do some? I'm okay penciling in some of the like no-go spaces. So the question is, can I fit 2 A's and a B in here? B, yes, I can perfectly. There we go. There's one A, there's another A, and there's a B. Neat. That's pretty promising that I've got the right rule there. Okay, we've got some more of these. We've got an X and we've got a dot. What's going on? There's some mysteries going on. AABBC. AABBC. And all of these need to be covered, but we don't have any letters, so there's no like distinct region like constraints. So AABBC, and what's that going to be in terms of number of things filled in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many spaces do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2 can be empty. All of these need to be covered. You need to be covered, which means either like, okay, let's maybe use this again. It's not rubbing off super well. There we go. So this either needs to be covered with a B or a C. So if we were to do that, what would that mean about you? Well, it would mean you need to cover it by a C or an A. Oh, actually, there's a better deduction here. Oh, actually, no, there isn't. Well, at least there might be, but the thing I'm thinking of is not necessarily better. I was thinking like, oh, this can't be a C. No, it can, because it can be joined to the other stuff. Oh, interesting. AABBC. And we're going to have 2 spare things at the end. Curious. Well, that is interesting about these 2 then. Like I can imagine like an A and a B. I think we're gonna have one left over here, right? Is that true? No, not if that's a B and that's an A. That's a C. And then we have an A and a B left. Well, I can see that isn't possible. Yeah, okay. Wait, how many dots are there to cover? 1, 2, 3, 4, 5, 6, 7. Okay, so we've got 5 shapes. So obviously some of the shapes are going to have 2 things in them. What's a good way of thinking about this? What is a good way of thinking about this? So we don't want to leave like 2 spaces over here, because if we did, we'd have to like use an A up here or something. What, like 2 A's and a C? I can see how that easily becomes a problem. So if we try and maximize the usage on the right, that would mean like, well, I also probably don't want a shape that doesn't have any. I don't think I can get 3 under a single shape, right? No, definitely not. Okay, what does that tell me? I've got 7 dots to cover. I can't get 3 under a single shape. I've got 5 shapes. So that means there's going to have to be 2 2s, at least. Yes, there have to be 2 shapes with a 2 under them. Now, if that's the case, okay, this is the way to do it, right? If that's the case, then where can that be done? Well, it could be done not with you. It could be done with you. But I think then we start having problems with you. You'd have to be a C. That's maybe fine. A, B, but then we don't have any space for the A anymore. Yeah, we do also have to get 2 A's in there, so don't forget that. Another place we can do it is here, B, and then like obviously we can get those with an A. And then I guess an A there, a C there, and a B there. Is that everything? A, B, B, C. It is. And we've got 2 left over. That felt pretty constrained. I don't know if I proved it. It's always scary moving on without definitely feeling fully like you've proven it. Okay. So the whole theory was 2 of them are going to have 2. Yeah, like there's no place I can get 3 under it. And there's not many places where we can do 2 without like just blocking off a bunch of things. That feels right, isn't it? There and there feels like the best place to do 2 without blocking other things off. Yeah, it feels good. I'm happy with that. Let's try not to forget what I've just drawn. Over here. And then that was B, A, B, C, B, A. Cool. Moving on. Six. A, B, C, 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 C. C. It's 5 C's, A and a B. Okay, well, so we know one thing. Let's maybe do it with the plastic sheet, even though there are some things there that I can tell quite easily. The plastic sheet's going to get scruffier and scruffier as we go through this book. C, X, X, X. Okay. Okay, so the C's, when they're not constrained by like a letter on the grid, are interesting. They just sort of like add to the whatever shape we've drawn. But U needs to be inside a B. That's interesting. And U need to be covered up. Interesting. Whoa. Okay, so where could this B go that even leaves space for an A that isn't connected to you? Like that and like that, but then we'd end up being connected to that. So if this goes up, if this B goes vertically, then it'd have to cover that. At which point I don't think there's space left for an A. There isn't. No. So the B must be going horizontally. So it's either there or there. I think that space doesn't leave anything for an A, so the B would have to be like that. And that means the A has to be there. Then do we have space for the remaining 4 C's? Well, one's going to have to go there. One's going to have to go there. 1, 2, 3, 4. Oh yeah, 4, 5. Perfect. Okay. That works for me. So there's a C. Let's move over here. There's a C here. There's a C here. There's a B across this way. Is that right? Yes. C down in this space to stay disconnected from that B. A up in this corner. There's a C attached to that. Is that all of them? No, there's another C here. 1, 2, 3, 4, 5 C's, a B and an A. Cool. Alrighty, 21. 4 B's, 3 C's. Wait. Oh, okay, yes. Yes, okay. Got it. I understand. So there's an A on the grid. You need to be in an A-shaped region. We're going to make an A-shaped region out of C's. Got it. So there are going to be 3 C's down here. And then we're going to have to be disconnected from that. So what are the ways of arranging that? I don't think there are too many, actually. Yeah. So, like, it could be like that, which would leave the most space. So it's almost certainly going to be that. And then all the B's have to be disconnected from it. Okay, should we just let's just like do this and prove that it's not going to work for the rest of the B's. So those are the 3 C's, and then 4 B's got to get in there. Well, they can't go there or there, so this is feeling bad already, isn't it? It can't go up there. I mean, it's immediately bad. Yeah, and it's going to be similar with the other way around, isn't it? like that. Cross, 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 cross. Yeah, there's no way the 4B's are fitting in. So almost certainly the 3C's are going here, here, and here. And then there's some way of fitting in the 4B's like this. Is there? Is there? One. So that's off, that's off, that's off. Is there? 1, 2, 3. I can't make an A out of B shapes, so yeah, I think that's right. 1, 2, 1, 2, 3. 1, 2, 3. 1, 2, 3. Am I wrong about the other ways that this could be laid out? Let's just do this again. So that way around. 1. Oh, I'm wrong. I'm wrong about this one. Whoa. 1, 2, 3, 4. That's interesting. So that layout for the C's is actually better. Huh, that's cool. It feels so weird, but I guess it's because... I mean, I find it even hard to say why. Because when it's like this, it leaves that as an X, and then you can't fit one in here, so those two would have to come down. But then there's no space in the, like, because it creates a kind of diagonal cutoff here. Whereas this way around, there's like space for 2 over here, and 1. I mean, I'm certain that's the solution, but whoa, it's interesting that the A has to go that way around, and by A I mean the 3 C's. Okay. So that's a C, that's a C, that's a C. Then those are cut off. So there's going to be a B down here. B, B, and another B. There we go. 22. Oh gosh, look at this. C, 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 C. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we're going to have 4 A shapes that are distinct from each other, I'm assuming. Wait, so what was it? 13? And that would be 12 already. Okay. So that tells me a lot. Okay, so I think I have seen this puzzle. I think I maybe remember something about it. There's some sneakiness to it. So, okay, let's get the plastic sheet. So the fact that all 4 of the A shapes would end up being almost all of them, we'd have 1 left over, makes it feel like at least, if we put 4 A's in here, they're going to have to cover, like it's going to have to do that, right? And that, and like that, and like that. And I think there's basically no way of positioning those such that there's a space left that isn't adjacent to all of them. I believe. I basically remember the sneaky trick here, but I want to like get there. And so is it okay? So is it necessarily true? Because like one of those could be covered by the remaining C, but like okay, let's say that was covered by a C that's going to have to be distinct from every other A shape. Then where do you go? Yeah, that's where this comes down. That's what this comes down to. They can't be distinct shapes. The ones with the dots in can't be distinct from the A's, because, well, this A can't go adjacent to that A, right? And so the shape has to stay separate. So the A would have to go into that space, or because it'd have to go that way and then out. Yeah, so they'd all have to go that way and out. Therefore, since they'd have to go that way and they'd be adjacent to these, it'd have to cover that. But then, as we've just seen, once they've done that, once they've done that, I don't think there's any way of positioning these two such that the spaces that aren't adjacent to them. Yeah, for sure. Okay, so the sneaky trick is, I think that's still true. That's still true, because otherwise we're going to go adjacent to these dots and have to make a non-A shape. So I think those do go out like that, but I think one of the A shapes is like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 4 more to do. Oh, there's not spaces for them. That doesn't make sense. Oh, no, okay. No. Yes, I see. Maybe it's these two and those two? It could be. Could it be all of them? Well, so then that cuts off this. That needs to be covered up. It doesn't have to be an A shape. You do need an A shape. How many more do we need? 1, 2, 3, 4, 5. We need 8 more. If we connected those two, that would be 3, but then we'd only have space for 4 more. So that wouldn't be enough. So what if these went like out? That would be bad. Or like this way? No, that's also bad. Okay, how is this done? 1, 2, 3, 4, 5. There are definitely 13, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's 13. Okay, how is this done? Ooh. Let me put that there. They can't go through the middle, because then it would definitely make a non-A-shaped shape. Non-A-shaped region, I guess, is a better way of saying it. And they can't go next to those dots. So how do we get enough? Like, I think one of the things that bothers me is cutting off like all of these 4. But I don't see how I'd avoid that. Well, unless you're going there. Isn't this what I tried? That's 9. We need 4 more. It's just not going to happen. Because these can't have anything. Like, if we cut off that. Okay. So we've put in 2 more. Great. Okay, so it's not that. What's the sneaky way of doing this? Again, it can't go adjacent to the dot. But like this can go here. That is an option. If they're both pointing, if they're both covering 2 like that, what's the result of that? That's crossed off, crossed off, crossed off, crossed off, crossed off, crossed off. There's not even space for, there's only space for 6 more, so we get to 12. Yes. Which isn't the right amount. Okay. This is such a sneaky puzzle. How can it be done? How can it be done? Why haven't I tried? Have I done this, that? So that's 9, and we need 4 more. Oh, perfect. 4 more like that, right? That's how it's done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There we go. Alrighty. Very clever. So that's like that. These go out. I kind of thought I tried that. I guess I misremembered. And then C, 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 C. Alrighty, that's actually the end of the section. So I think I'll call it there and we'll move on to phrasing next time. So C for that. Oh, it looks like we have a new letter. All right, see you for a new letter next time. Goodbye, folks.